Greetings and welcome to the video. In this video we'll be exploring a proof of concept that I've done up that's centered around webhooks and callbacks and implementing them in Ansible Tower or Ansible Automation Platform. In this particular case we'll be taking a look at Ansible Automation Platform 2.1. However, this is also applicable to Ansible Tower 3.8. Alright, let's go ahead and take a look at the diagram and get an idea of the workflow that we're after. In this particular instance, we'll be utilizing Gitlab for our originating source. So from that originating source, we'll reach out to our automation controller, which will in turn kick off a job template. Now, during the execution of these tasks, whether they be successes or failures, we can then perform any additional tasks if we so desire, and then return the status of these tasks back to the originating source. In this case, Gitlab. So as mentioned, we're using Gitlab as our originating source. So inside of Gitlab, I've created a basic repository with a couple folders called failed jobs and successful jobs. And these will catch the return statuses from Automation Platform. In addition to the main branch, I've also created a second branch called Tower Deploy. This branch is wholly responsible for triggering that job in Automation Platform to kick off. If we take a look at the Webhooks section of this repository, this is where we will feed a webhook URL, a token, and some trigger to trigger that webhook callback. In this case, we are going to trigger on a push event to that Tower Deploy branch. Taking a look at the job template in Automation Platform, we can see that there's not too much different from any other job template. However, if we scroll down here to the bottom, we can see there's an option to enable webhook. Now if we check this box, we'll be able to select between GitHub and Gitlab. Once you select this service and hit save, it'll generate that webhook URL and a token for you. It is that URL and that token that we used back on Gitlab in order to get that webhook set up. So without any further ado, let's go ahead and hop back over to Gitlab and take a look at our Tower Deploy branch. And if you notice, we also did a README for this one as well, with a lovely little note that's just basically letting you know, we set this up as a push event, so anything goes. Any update to this repository will trigger off that workflow. In this case, we use a nice little file called trigger job, and I like just sticking the timestamp in here. So let's edit this and stick the current timestamp in here. And once we push commit, this is going to trigger that webhook. It's going to trigger that callback over to Ansible Automation Platform. And it happens pretty much instantaneously, so we'll have to be ready for this. Let's go ahead and hit commit. And our changes are committed. And look, flipping back over here to Automation Platform, our job is already running. And this job is actually a little bit of funny job in that it also kicks off another job. So this is really the meat of it, is this nmem test. So this is what we'll dive into and take a closer look at once this is finished. Alright, so let's take a look at what this did. If we scroll up here. So the first thing we did is we're using extra vars to pass it a host name for a host to run on. In this case, labdev1. We create that inventory. And then we start to run additional tasks on that. In this case, we are going to verify the existence and contents of some arbitrary file on the file system. If this file exists, we could perform an additional task. In this case, we are launching an additional job template to remove that file. And then on line 23 here, this is the bit that is of most interest. This is where we are returning that job status to the originating source, in this case, GitLab. And then a debug message just letting us know that the job's complete. And likewise, if we flip back over to jobs, now it did say that it was launching the file removal task, which it did indeed. And this one, again, is very simple. Creates an in-memory inventory for that host passed via extra vars. And it removes that requested file from that host. Now, this particular workflow was flipping back over to the diagram. No, I don't want to refresh the browser. This would be simulating the success condition. So we've completely run through, all tasks were successful, we've returned the data back to the originating source. So what we're going to do is we're going to trigger this job again. I'm going to flip over to GitLab and do the same thing. We'll just stick in a little timestamp here to trigger this job again. And what this will do, because that file doesn't exist, well, now we're going to run into an error condition. So let's trigger this and see what happens with said error condition. Commit these changes and flip over here to our platform. And there it goes. And let's follow along with this and see what happens. All right. Scroll up here. So here we did the same thing. We passed the host name via extra vars. We created our in-memory inventory. Based on that, we start trying to remediate that host, same way as previous. However, unlike the previous run, this file no longer exists. We've caught an error. And if you notice, we actually have caught that error. We get an exception caught. Hey, we got to run some rescue tasks now. Ignoring the warnings. One of these tasks that we want to follow up with is, hey, the file doesn't exist. Let's create it, right? It makes logical sense. In addition to that, we also want to know what the status is. So, flipping back over to the diagram, and following our task fail, we're also doing the same thing, right? We've run into that fail condition. We're doing anything that we may need to do to rectify that, and then returning a status back to that originating source. And then the same thing, nice little job complete message letting us know that our tower provision host was labdev1 and that the provision was actually a failure. Even though we rectified it in this instance, it was still a failure. Alright, so let's go ahead and flip back over to GitLab. And we will switch over to the main branch. And already we can see that there are some commit messages. So if we take a look at our successful jobs, we have a successful callback from automation platform from our play into Git to commit that status update. Likewise, if we take a look at fail jobs and look at the job that we last ran, we can also see its job status. Alright, let's take a quick look at the code and see what we've got going on here. So as previously mentioned, we are creating an in-memory inventory to run a series of tasks against. The first section of this playbook does just that. The second portion of this playbook utilizes block, rescue, and always in order to not only run these tasks, but handle the exceptions. So basically what this will do, like normal plays, is it will run one task up to the other. If they succeed, all is well. We will return the job data to the originating source. If any of these tasks fail, however, then we enter the rescue set of tasks that will perform whatever it is that they need to perform. In this case, if our file is missing, we create the missing file. But ultimately, we end up returning data to the originating source. Regardless of if tasks fail or succeed, we can also choose to always run something. In this case, we're just doing a debug message to let us know that the job has been completed. Now, as far as returning data back to the originating source, if we scroll back up here, both the success and fail conditions are similar in this regard, in that we make use of the URI module in order to make a HTTP post request back to Gitlab's callback, or Gitlab's webhook rather, in order to post our commit message. So in conclusion and wrapping up, I just wanted to thank you guys for watching. And let you know that we only briefly touched on webhooks and callbacks and how they relate to Ansible automation platform. In this case, we are using a Git repository to both trigger a job and then receive job data back into that repository, right? Yeah, hopefully it's given you some ideas and something to work with. And the repository for this will be posted below in the description of the video. But thanks so much for watching, and see you next time.